So hello guys, welcome back to another video. In this video, we will be discussing with our deletion methods, how we will delete at head, delete at tail, and delete at position in case of single linked list. So in the previous video, we have seen all the insertion methods, how we will insert at head, insert at tail, and insert at position. In this video, we will be seeing all our deletion methods. Okay. So if you have not watched the insertion methods, so the video is in the playlist, so you can watch it from there. Okay. So let's begin. So now let's see what are the three uh, methods are there in case of deletion when we are deleting a node from a single linked list. Suppose, let's take this as an example. Suppose this is my first node. Suppose this is my linked list. Okay. And suppose I want to delete this header node. So what I will do, let's see first insert delete at head. So what I will do, I will move this head over here. First I will create a temporary node, as you already know, which will basically point to my header. Now this will be my temp, and I will update my head to heads next, and now I will delete temp. So this is pretty simple, the code of deleted head. So let me write it down, the pseudo code. In case of deletion, you should always check if my head is equal to null. If head is equal to null, then you will simply need to return. Okay, else what you will do, you will first create a temporary node which will basically point to head. You will update the head to heads next, and then what you will do, you will delete your temp. So this is how you will delete your node in case of a in linked list basically. This is basically in Java, you don't need to specify this delete temp because the garbage collector will do it automatically. But whereas in case of if you are using C++ as your language, then you need to specify it that delete temp. So it will basically delete this temporary node. Okay. So yeah. So let's write our code. So this is delete at head. Now I will pass my head. Now what I will do, I had already told you that if my head is null, what we will do, we will return. Else what we will do, we will create a temporary node which will basically point to head, and what we will do, we will update our head to heads next, and we will delete our temp. So this is just three lines of code that you need to remember. Now let's see. So we will call delete at head, and we will be passing head as our out, and then we will do traversal also, check whether we are getting right output or not. So suppose I want at first position 10. Sorry, this was first the test cases that I need to specify. 5 nodes we want. In first position I want 10. In second position I want 45. In second position I want 78. In first position again I want 89. And at fifth position I want 100. So as you can see, our 89 node is deleted from our linked list, has successfully been deleted. Okay, so this is the code for deleting a node at head. Now let's see how we will delete the node at tail. So for deleting a node at tail, what you need to know is, you will, let me erase it first and then I will explain. So what you will do is, the you will create a temporary node which will again basically point to my head, and what you will do, while my temps next is not equal to null. So basically what I mean to say is, while my temps next is not equal to null, I will update my temp to temps next. Okay, and then once my temps next is null, then what I will do, I will delete my temps next, and I will update my temps next to null basically. So let me write down the pseudo code. So then you will understood what I mean to say is, first the base case remains the same. If head is null, then return, and then what I will do, I will create temp which will basically point to head, and then what I will do, while temps next is not equal to null, what we will do, we will we will write temp is equal to temps next. And once our temps next is null, what we will do, we will suppose create a node star node to delete, which will be basically temps next, and let's write delete node to delete, and then we will point temps next to null. Okay, so this is the code. So let me explain you this with an example. So suppose this is our linked list. So this is basically our linked list. I want to delete at tail, that is I want to delete this 3 node. So what I will do is I will initially set my temp to my head, and what I will do, while temps next is not equal to null, I will move my temp to temps next. So as you can see, temps next is 3, and which is basically not equal to null. I will update my temp to temps next, and this will be move over here. Now I will again check, is temps next equal to null? It's not equal to null, so it is equal to null. So what we will do, we will perform these 3 lines of code. That is, we will create a node which will basically be node to delete, and which will be basically temps next, which is basically 3. Okay, then we will delete this node and we will point this temps next to null. So this was the simple code. So let's write it down. Void delete at tail node star and head, and what I will do, the base case remains the same, because if the head is null, there's nothing inside my linked list. Else what I will do is I will copy this code. So as you can see, I had copied the same code what I had written. So what we will do, we will move this, and what we will do, we will delete node. Okay, so let's call this delete at tail. As you can see, we will want 5 nodes in our linked list. At first position we want 10, at second I want 15, at one I want 78, suppose I want second at again 56, and at 89, at third I want 56. When I will enter 56 or whatever value, you will notice that this 15 will get deleted. Okay, so as you can see, our node 15 is successfully getting deleted from our linked list. So this is the code for deleting the node at the tail. Okay, so next is delete at position. So how you will delete a node at particular position or whatever index that is given to you by a particular user. Okay, so delete at position. Okay, you will create a head node, and also you need the position. And for deleting a node at particular position, what you will do is, let me create another page. So simple. So what you will do is, so suppose this is my linked list again, and I may draw 3 4 nodes, and we will see what the logic says. And this is pointing to null. So what it basically deleting its position means that we want to delete a node at a particular index. So this is my first position, second, third, and fourth. Now what I will do is I will mark this as my 10th, and I will create a variable count similar to what we had done in my inserted position, because we need to find the position of that particular node which we want to delete, or the position at which the user want to delete a particular node. So I will create a count, initially set it to 1, and what we will do, let me write down the pseudocode, and then let me uh, first write down the pseudocode, then we will try run the code. So what I will do is I will first check the base case, that is if head is equal to null, then return. Else what we will do, we will, let me write it in C++ fashion so that later on we might copy this code, and we don't need to again rewrite this code. Okay, what we will do is we will return, else what I will do, we will create a temporary node which will basically initially points to head, and I will create a count which is 1, and what I will do, while my count is not equal to position, whatever position is given to me, I will do count plus equal to 1 and temp is equal to temps next. Okay, then what I will do, once I got the position, whatever I will do, I will once I will got the position, so what I will do is I will also I need to keep track of, I need to create another node which is basically initially null. What I will do, and I will mm, previous to current, also over here previous to current, and sorry, current, it's not current, it's 10. And what I will do, I will mark my previous next as temps next, and delete previous next. So let me explain you what I had written over here. So let me zoom out and then you will get the clarity. Okay, so what I had written over here is, if head is equal to null, then simply return. This is the base case, you already know that. So now what I had done is I had created a temporary node which is initially pointing to my head, and I had created another node that is my previous, which is initially pointing to null. Okay, now what is the use of this previous node is, because I had also created a count which is initially set to 1. So let's see what we have done over here is, while my count is not equal to position, so suppose the position given to me is 3, I want the node to be deleted is 3. So what I will do is I will check while count is not equal to position, so is 1 not equal to 3? Yes. So what it will do, it will update the count to 2, and what it will do, it will update my previous. First we need to update the previous before moving this temp to next, because if we first move this temp to next, now then the previous will point to this temp. So first we need to update our previous to this particular value temp, and then we will update our temp to this particular value. Okay. Next, we will again check, is my count not equal to position? Yes, my count is not equal to position because 2 is not equal to 3, so it will update the count to 1. And now my previous again will point to this temp, and now this temp will point to this particular node that we want to delete. And what it will, again it will check while count is not equal to null, but this time our 3 is equal to 3. So what it will do, it will first we need to update this previous next connection to our temps next, because now we want to delete this node, so this connection will no longer be there. So we will update first this link, and then we will delete this particular node. Okay, previous next. Okay, so this is the code. So let's write it down here in our VS code, and then we'll see whether it is giving us the right output or no. Let me copy this, sorry, and let me copy it over here. So let's format our document. Yeah, now it's correct. So let's run. So it's the position where I want to delete, and let's create the test cases for T1. How many nodes I want to delete at and what position I want to delete. Also over here, we need to cover our two edge cases also, because if my position is 1, I will use my deleted head logic. So this is another case that you need to keep it in your mind, that if my position is 1, I will use deleted head logic. And also what I will check over here, the same thing, that whether my temps next is null. If my temps next is null, because no, it will work for this also. Let's check. Suppose I want to delete the node at position 4. So if it is at position 1, I will simply use deleted head logic, and if it is at tail, So let's see whether our code is working fine for the tail condition or not. So initially I want to delete a node at position 4. So this is my position, and initially my count is 1. So what it will do is, let me clear this for you so that you should understand this better. So let's make this. So this is our first position, second, third, and fourth. I want to delete the node at fourth position. So what I will do, I had created a temp and I had created my previous. Now what I will do is, I will check while my if head is equal to null, so it's not the case. Now I will create a temporary node. I had initialize my count to 1, and now I will initialize my previous to null, and then I will check my 1 is my 1 equal to the position, so no. So I will update my count to 2. So I will update my count to 2 and I will move the stem to over here. But before that, I will update my previous to this first node, and then I will move this temp to temps next. Then I will again check while my temps, while my count is not equal to position, my 2 is not equal to position, I will update my count to 3. What I will do, and I will update my previous to this temp, and I will update my temp to temps next. Okay, then what I will do, I will check is my 3 not equal to 4. Yes, it's not equal to 4, so it will update my count to 4, and it will move the stem to this particular fourth node, and before that it will update my previous. Now what it will do, it will again check my 4 is not equal to 4, but this time my 4 is equal to 4. So what it will do, it will point this previous next to temps next, because temps next is null, so it will update this null and it will delete previous next. So it will work for this tail condition also. So this was the thing that I want to show you, that for tail case we don't need to specify separately. It will work for that also. Okay, so let's run our code. So let's first let give the test cases. So end position 1, where the position I want to delete, and delete at position the head and the position, and also we need to position 1. I need to use our code for the head. If my position is 1, we will use delete at head logic. What is that? That is, we will use delete at head for this particular head, and we will simply return. Now let's run. Suppose I want 5 nodes in my linked list. At first position I want 15, at second I want 45, at second I want 78, at fourth I want 10, and at first I want 20. So now it will ask you how many nodes you want to delete. Suppose if I want to delete 3 nodes, and the first node that I want to delete is at head, that is at position first. So we need to specify our traversal also, because after that we will see what is happening. So traversal and head. Let's rerun our program. 5 nodes, 1. At 1 I want 10, 2 I want 13, 2, 11, 4th, 56, and at first I want 78. So now it will ask you how many nodes you want to delete. So I want 3 nodes to be deleted. At position 1 I want to delete. Oh, sorry. So it means there is something wrong inside our code. So let's see what's wrong inside our code. So if position is 1, we need to delete at head, and we need to return. So this will basically be node star, because we are updating our head every time. So return head, and for this also we will return head, because after when we are traversing, so our head should be updated each and every time. So that's why it's running into an infinite loop. So let's see whether it is working or not, where it's giving error, that is return. So return head. So if it's null, you will simply do return null. Okay, let's rerun this program. I want 5 nodes in my list: 10, 12, 45, 78, and 89. Now I want 3 nodes to be deleted. At position 1, I want to delete the node. As you can see, we have successfully deleted our node because the problem was that we were not updating our head, because every time whenever you are deleting a node, you need to update your head, because when we are traversing our linked list, the head should be updated because it's the position where we will start traversing our linked list. Okay, so let's see for our tail also. So I want to delete the node at fourth position. So as you can see, it has successfully deleted the 78 node at the tail. So let's see for I want to delete the node at second position, so whether it will delete 45 or not. Oh, it's again ran into an infinite loop. So it means there is something mistake in my over here. So what I had done is, while sorry, not over here, over here, deleted position, updated my count. While my count is not equal to position, while my count is not equal to position, what I will do is, uh, I will update my count to next, previous equal to temp, temp is equal to temps next, and previous next is equal to temps next, uh, and delete previous next and return head. So why it's giving us a wrong? So let's see. So this is our first node, this is our second node, this is our third node, and this is our fourth node. So I want to delete the node at second position. So what it will do, it will mark this as my temp. Okay, and this will be my previous. Okay, so and count will be 1. So what it will do is count not equal to position, so it's not equal to position, so it will update count to 2, it will update previous to temp, and it will move temp to temps next. Now it is at my position, so now it will check whether my count is not equal to position. Yes, my count is equal to position. So what I had done is, I had done previous next will point to temps next, which is basically this 3, and I had done delete previous next, so it will delete this basically. So but before deleting this, you also need to update your temps next to null. So let's see if that change will work or not. Before deleting previous next, what I will do, I will do temps next will be null. So let's rerun our code. So if there are 3 nodes in our linked list, 1 at 10, 2 at 12, 2 at 45. Suppose I want to delete only one node at position 2. Let's see whether it is giving us right output or not. No, there is some mistake. So I'm not getting where exactly we had done the mistake. Temp is head. So what we are doing, we are updating the count, and similarly for that we are doing over here. So uh, so if my position is 1, I will delete at head and return my head. Previous is null, count is 1. Current is head, temp is head. And while count is not equal to position, I will previous to temp update the current to current temps next. Yes, we have done that. And after that, what we will do is, we will basically uh, delete that particular node. Previous next will point to, we need to we will point our previous next to temps next, and then we will temps next will point to null, and then we will delete our. So we need not to delete this, we need to delete, simply we can write temp. Okay, and also this will work. I don't know why. This should work. So let's see whether now it's working or not. Let's rerun. Let's hope for the best. 1 at 1, 2 at 2, and at 2 I want 10. I want to delete only one node at position second. So yeah, so now our code has successfully been worked. So what's the mistake in the code was that we were deleting previous next. So instead that we will simply delete temp, and also I had used while count is less than position. You can write not equal to also. Let's see whether it will work or not. So 1 at 1, 1 at 2, and at 3 I want 3. So let's see, I want to delete only one node at position 2. So yeah, it's working fine for that also. So you can write it like that also. So this was how you will delete your nodes at your head, at your tail, and at your index, whatever position you want to give. So from my side, I had successfully completed my single linked list. So if you have any queries, you can ask me in my comment section. And also please like, share, and subscribe. So it will motivate me to make more such videos. So thank you. In the next video, we will be discussing with a doubly linked list. Yeah.